Welcome, everybody. It's good to see you all. This is yet another Unity Open Development meeting, but there is something special about this meeting compared to others because Unity is now part of main. Thank you, Tianchi, for making the thread on GitHub to have the vote. So Unity is now in main. Yes, this is maybe we should even call this the TVM main development thread, main development open development discussion meeting. I don't know. That's something actually that we should figure out, and I put it top on the agenda. Should anything change now that Unity is in main? There might be procedural questions we want to consider because the change was approved, with unanimous votes. A lot of people voted in that thread. But we didn't discuss exactly what this meeting should be about now that Unity is part of main. Should we do anything differently? In particular, I would like to figure out. So, one thing, what started my thinking on this issue, first of all, is now that Unity is in main, that means Relax is in main, which means we should have documentation on Relax. I think now it's being advertised, I think, kind of more prominently. This is not just some experiment, this is part of TVM now. So we should strive to have some documentation up. But also, in terms of procedure, now that Unity is part of main, does that mean we should use all the same processes for changing Unity for changing Unity features that we have used for other TVM features? Should we write RFCs for major features nowadays? What should be different? I think we should articulate at least what the expectations are going to be. I assume this meeting will probably continue in its current form, but that's also up for discussion. Tianchi, you are here, thankfully, so I hope you might be able to give some suggestions if perhaps you had thought about this when you were proposing the motion to merge Unity into main. If you have any
Yeah, I
opening
think
thoughts.
one of the things that I think is still interesting now is with seems that as the community we still need velocity, right? So in terms of we want to be able to bring in new features quickly and be able to document things. So I definitely love us to continue that momentum of the European Unity. I do think that given there's no TVM Open Dev meeting now, maybe we can just rename it as TVM Open Dev meeting, and that allows people to bring agenda as well. And yeah, but definitely agree, like we need documents and to make things accessible, and even maybe we should start think about deprecating some of the older components so that we can become more focused on getting the current flow running. Another thing that I think is useful is start to think about categorizing test cases. Like for a lot of old, like the CI is running very long, right, in the main branch. So it will be useful to categorize, hey, ideally we need a lot more unit test cases where you just compare like a single pass before, after. A lot of the current legacy tests are structured as integration tests. Like I want to test X, I'll just go and run build, and then you compare the outcome. So that's usually time consuming. So it would be useful to start categorizing the test, and maybe we can consider move some of the legacy test that runs longer to nightly, so that and capture more of the non-unit test. I think that's another item that would definitely benefit the main evolution here. Yeah.
Thank you for raising the point about test cases. Yeah, I think I wonder that should probably be a community initiative then, triaging test cases, figuring out what should be updated, what should be changed. So that makes sense. I certainly agree that it's important to maintain momentum. One of the reasons I think Unity has generated a lot of excitement is because of projects like MLC. That Unity has been used to support the latest models pretty much as soon as they're published. It's certainly exciting. So I'm not sure. Yeah, I guess what takeaway then should we have? Should like suppose we want to make changes to Relax. Should we continue as before? Is there any issue with that?
Sorry, I'm muted.
You're muted.
I feel like it's still okay as long as we are. I think we need discussion, right, on forums and so on. And I feel like we don't have to go through. I think it really depends on whether or not we are starting to step into each other's toes, right? And I feel like as of now, it's not yet the case, and that would mean that we could try to I feel like we should still move fast, like in terms of Relax, to make sure that there are different components in TVM, and I feel like Relax is a component that still, in the age of generative AI, you need to just keep up, right? So being able to move fast is useful, and also have ways to communicate, like through forums, through other means. I feel like is quite useful. So personally, I feel like we don't have to immediately go towards a more like a slow moving part, right? But maybe start documenting things that people start using, and then we will start to see interesting, and then we'll see how it goes. Yeah.
Okay. I mean, personally, I like this position, so we can certainly leave the topic open for discussion, and I'm happy to continue, working as we've been working. Yes, the floor is open if anyone else has thoughts on this subject. Okay, so I think maybe uh well, we'll see when it becomes a good idea. But I think eventually, yeah, we probably would want a topic on the discuss forum about procedures. I'm happy to continue as we were. We have a question in the chat. Uh, Siva asks, "Is Relay going to be deprecated going forward?" Uh, do we have an immediate answer?
I think the answer would be we will encourage everybody to move towards Relax because all the latest models like LLMs and all the other things, right, happens through the Relax API, and we learned a lot like when building Relay. So all those lessons are captured in the Relax right now. So being able to, you know, center our new development philosophy around Relax is certainly something that we want. This being said, Relay API as of now, right, is still being tested and maintained because we don't see community to immediately, be able to switch all their flows towards Relax. But I think, the new flows, like for example, if I'm working on LLMs or Stable Diffusion, or any of the Gen AI flow, I would imagine they should be on Relax, and gradually Relax will become more and more mature. So if you find there's a need on, a particular need that you would like to see in Relax, I think it's also a good time to open discuss forum and talk through them. Yeah. So I would
How
say,
about training
yeah.
support flags, which we don't have right now?
Can I say that again? Sorry.
How about training support, tuning? I mean,
It's a
sorry,
part.
it's
So
not
uh,
really.
I think Relax already have gradient support that's even better than what Relay have. And I know that one of the interns here, Yixing, he built a fine-tuning service on top of that. So definitely check it out. Yeah.
Okay, thanks. So there's going to be a collaborative effort in terms of bringing in the things which are missing in Relax. Right? For example, from Qualcomm point of view, we have Arduino texture support and all that. So we need to work on that and then get them working in the Relax as well, right?
That is a great question. I don't think we yet have a plan of directly bringing in like the extra support for like a Android texture immediately. This being said, I think, for example, actually the Relax path is more modular. For example, we could definitely have a memory planning path for 2D texture, right? And it also directly work with TensorIR, which means that I would imagine that it would be simpler actually to build a flow. But indeed, right now the original Arduino flow in Relay is not yet fully supported. What you mean is the texture memory allocation, right? So
Right,
so
right. You
we
need the compilation process, right, to and the memory planner associated with that.
yeah. So I would say it is not yet supported, but the current relaxed memory planning aggression is a directly extension from our previous memory allocator. So I think that would be an interesting extension. Like we should be able to get a memory planning working for Relax as well.
Okay.
And yeah, if you're interested, I think that's definitely a very useful thing to do. Yeah. And
Yeah, we are working on something in that direction. I just want to know what is the status of community.
sounds great. Yeah, sounds great. Yeah. And I think folks here like Stephen and others will be more than happy to support as well. Given the infrastructure is, I think, is gradually become more mature. Another advantage of Relax is that we do have better support for debugging, right? We have all those tensor based testing. So instead of trying to do end-to-end build tests, we will be able to, for example, when in memory planning, you will find that there are specific test cases for memory planning that directly say, here's the things before and here are the tensor after. Here's the TVM script after. And it's much more reliable actually in terms of what you can do on
Do
plan.
you have the end-to-end test cases for Relax similar to Relay? Because in Relay we have a bunch of front-end test cases, right?
Yeah, so in terms of end-to-end tests, actually the goal here in Relax, we want to structure it in mostly in unit test cases, right? Because end-to-end is expensive. So there are a few end-to-end test cases, and also a lot more are being structured in this dedicated flow. Like for example, if we have like MOCLM, right? So there are end-to-end compilation tests there. Yeah.
Okay.
But actually, if, for example, if there's a memory planning path for 2D memories, we would prefer to have unit test cases because that's going to reduce the CI time greatly. Like originally, we have a lot of the end-to-end test, and there are two issues. First, it's really hard to detect regressions when they happen, and then it's also hard to actually debug because you are seeing it through multiple cases. Yeah,
Yeah, that makes sense. Yeah, we'll try to enlighten that.
sounds great. Yeah.
All right, thank you. Thank you for the questions. Yes, actually, on the subject of gradients, I want to point out one difference between Relax and Relay is that Relax allows mutation, so that actually would make automatic differentiation easier to implement in Relax compared to Relay, because you can just use a packed func to do the gradient updates. You don't need to do anything special. In Relay, we had reference types to do this. There was a lot of shuffling around, and actually, it was probably because of the way references were implemented, it's probably less efficient than using a packed func to do gradient updates. So there are actually some advantages to Relax in this regard. Good thing to ask about. Okay, if so, it seems like my takeaway on this subject for now is that there's still a lot we have to figure out in terms of development. I guess as issues arise, people will make threads. Threads on the Discuss forum, I'm happy with that. We can revisit the subject if an issue arises. Of course, this meeting will continue to happen. I do want to say on documentation, I want to say two things. One, I made an RFC for a language specification for Relax. Those of you who had kept up with Relax's development, you'll know this draft will be very familiar because I had a PR giving a draft of the language specification. So now I'm making it official. So that might be part of the documentation. The second thing I want to say, if anyone has links to old Relax tutorials that we have had over the years, or the past 2 years to be precise, I would be interested in seeing them. I'm hoping to compile some of these old tutorials, bring them up to date, and contribute them to TVM's documentation. So because we've already written some material, I think now's a great time to start making it visible on the website. So if anyone has old links, I'm going to start digging through old notes to look for them. But if you know of examples, I'm happy to clean it up, try to get it to work if anything's become outdated. So let me know. Thank you. Okay. So if there's nothing else to say on procedural changes, I think we can move on to other points on the agenda. The next point on the agenda is one that I have raised before. I was hoping to get it visible to a wider audience, and I think we have a wider audience today. I wanted to talk about a pass I contributed a few weeks ago on automatically extracting data flow blocks from arbitrary code. So because we track purity in Relax, we can automatically figure out what parts of a given function are data flow. So what I wanted to get further discussion on are some of the implications here. One, this means it's no longer necessary for users to write out data flow blocks themselves. There's literally no advantage for writing out a data flow block yourself because the automatic extraction will always detect the same areas. So I wonder if we should advertise that. This would require us to make the data flow block extraction part of the normal compilation flow. So the last time we discussed this, we decided that actually doing this early in compilation might make sense. After normalization, this might make sense. It's something to consider. So I wanted thoughts on that. Should this be part of the normal compilation pipeline? And also whether we should tell users, don't worry about writing data flow blocks. There's no reason to manually write a data flow block. That I think is true. The second thing, though, is that this actually raises some interesting possibilities for phase ordering, because in our current compilation pipeline right now, there is a step where we get rid of all the data flow blocks. We say past this point there are no data flow blocks, and you don't need to think about them. But now that we can automatically extract data flow blocks, the question now is, does it make sense to have low-level passes that care about data flow blocks? Because now you could just run this. You could run this pass whenever you want and get data flow information again. What's the implication here? When I discussed this, I discussed this informally with Eric Lunderberg, and he pointed out that if we now that we have this extraction, we could actually just get rid of the requirements that, oh, hey, passes later in compilation can't use data flow because we got rid of it, which means it means that we have less complexity, right? It means we have one fewer dialect to worry about. Because if we have this line in the pipe, if we have this line in the compilation flow where we say past this point there are no data flow blocks, that means that makes it a new dialect. It means we have Relax without data flow blocks. But again, with this automatic extraction, we no longer need to draw such a line because now a pass can use it whenever we want. So yeah, I guess we should figure out what is the implication for phase ordering. Does this mean we should we allow then low-level passes to use data flow block information? My only concern here is that running this extraction could just increase compilation time. That's it's not free; it's a cost. So, the question is, what policy should we have? So, yes, I welcome any thoughts on how we should proceed with data flow blocks. I guess there's actually a second implication to the phase ordering issue. The second implication, though, is that we also get rid of purity tracking during our ordinary flow. There's a little pass that gets rid of purity tracking. For the data flow block extraction to work, we would also need to ensure that we do track purity in lower level passes. I have had a look at low level passes, and actually only call TIR rewrite. That's the only one that changes pure things to be impure. So it would not be that hard to keep track of purity at the low levels. So I think this is reasonable to do. The catch is, of course, this pass would have to update whether functions are pure or not. It would have to update the signatures. We might consider trying to automatically infer purity. The only reason we don't do this right now is because it would require potentially multiple passes through the module to figure it out. We've been trying to avoid that. So that's another concern. So to summarize, I guess I'll list the biggest points for our discussion. Number one, with the data flow block extraction pass, there's no reason for users to manually write data flow blocks. So I think what I'm proposing is to essentially declare this, in our documentation. Just say users don't need, don't even advertise data flow block to users. Just say we will automatically detect data flow blocks because we can. So we should put it early in compilation. Point number two on phase ordering. With this pass, we can consider we no longer need to enforce a phase ordering that any analysis that uses data flow blocks must come must come early. Now this would allow data flow analyses to come later. But it requires using this transformation. You have to get the data flow blocks back. So that's something to consider. It is a cost, so that is a trade-off. Additionally, the other bit of the trade-off is we would need to track purity at late stages of compilation in order to support this. So I'm curious about your thoughts. This is something I had not thought about before last week. We discussed it informally last week. So I welcome any feedback. Don't be
Yeah,
shy.
personally, I feel like we should reduce the amount of automatic magic in some sense. So having a pass to automatically turn things back onto the airflow is useful, and it's useful for developers to be able to, if they need it, they can use it. But I feel like for something that's always on, like we should have a few as possible. Like the I think the structure for deduction is the only one that's always on. And I think that kind of helps to build up it's like just like in PyTorch, a lot of like AM automatic mixed precision passes, like being able to reason about them is useful. Yeah.
What's your, I guess, what is your rationale for not automating this part?
So I think the main thing is, first for most of the passes, right, would already preserve. Either they are in the early phase, so they have to preserve their flow blocks, right? So in that case, you don't have to use it. Or in the later phase, data flow information is not necessarily useful. So the reason why we have things like a structure info deduction always on is because it's hard for pass to manually do that, right? So, but for data flow, I feel like most of the passes they should be able to preserve it anyway. So yeah.
Okay. I guess, yeah, potentially. So yeah, we could just tell users, I guess, that they can use that if they want to. That's one option. Sure. Let
Yeah,
me just update
sometimes
the notes.
sometimes I forgot to read all the data flow explicitly. So that's having a patch like this, I think it's useful as well. Yeah.
Yeah, personally, I'm in favor of of just always having it because here's my reasoning. Why do I think this should always be on? Because fundamentally, a data flow block, I would call that compiler internal information. I really don't think that a user needs to, that from the front end point of view, I don't think that it's important information whether something is part of a data flow block, especially when the language tracks purity, right? So it means the compiler has the ability to infer whether something's data flow. So that's why I would support again, just inferring it, simplifying the front end interface as a result. So it's easier for users.
In that case, maybe we could have an option in parser, right? So that's more like, when you get it in, you run it once. And then all the passes, you
Yes.
don't have to run always on. Yeah.
Oh yes. Yeah. To clarify, that's what I meant. Yes, use it once. Because yeah, it would definitely be a little extreme to use it after every pass. So yes. Okay. I mean, we can make it an option. I'll make a PR, and then we can discuss on the PR. Because I think again, it's easier for users, and yes, it only needs to happen once. I guess Eric, the last time I brought this up, he had an example of a potential phase ordering issue that could result, but I think we'll see if he can come up with a test case. I don't think this should cause any issues. All right, I'm updating the notes for a second. If others have points to make, that would be a good time. Any thoughts in particular on the question of data flow block extraction late in compilation? Because as I mentioned, it would take a little bit of work to make it feasible. Namely, tracking purity would be necessary to make that feasible. Sometimes it is useful, or at least there have been times where I have wanted to. I guess it's a little bit speculative. Because late in compilation, chances are you're doing low-level things like like lowering call TIR into calls to prim funcs directly. So I guess we can see if the need arises. It would be nice. The reason I bring it up is because this could potentially get rid of a requirement in our phase ordering. Like it would simplify the phase ordering. We can handle that on a case by case basis. I think that's maybe that's the right answer. Cross the bridge, or cross the bridge when we get to it. Okay, then. If there are no further thoughts, we can move on to the next topic, which relates to something that's been a feature we've wanted for a long time, heterogeneous execution. So we talked about this in a previous meeting, but we didn't have time for further discussion. This time we have plenty of time for further discussion. So Young, would you like to refresh our memories on heterogeneous execution?
Sure. Yeah, we introduced the V device, the virtual device, as a member of the structure info, and the virtual V device node is in the global info of the R module. So the relax function and the TR print func should be should have the access to the the V device information because it's in the global info map of the R module. We introduced the real-life V device path to help user to propagate all the V device information across the R module. Also, we offered option operator like hint on device to help user to hint a specific load to be on a specific V device. Also, user has the option to manually annotate the V device information just through the tensor structure info or the tensor in the front end to do that kind of thing. In the backend, we introduced the packed func named to V device to do to copy ND array from a device to another device to do this kind of thing. This is the overall picture about the heterogeneous stuff. So I think for this discussion, any questions?
Thank you, Young. I know you had a Notion page with examples the last time. Do you still have that? It could be useful visual aid.
Yeah. Give me 1 second. Let me
Thanks.
click it out. Share my screen. Can you see my screen?
Yes, thank you.
Yes, we can see your screen.
Yeah, here is, for example, here is R in the relax R module, we have we can allocate, for example, we can use the 2V device to copy copies the LV0. LV0 is supposed to be on LLVM. We can copy it to CUDA device. Then we can do the following up MATMO on CUDA. We can do this kind of thing using 2V device to do the real copy. We introduced 2V device operator and a hint-on device hyper operators to help user to allocate to tell the program this load is supposed to be a specific device, this kind of thing. For example, we can hint, for example, we don't, for this relax function, we don't annotate the VDevice in the function input X, Y, Z. We don't see any VDevice information here. Then in the data flow block, we can hint the input Y to be on CPU. This kind of thing. Then we will know Y is supposed on CPU. Then we can allocate it using the realize device path to do this kind of thing. Sorry, I don't prepare the demo today. If you
No,
guys
this is a good example. It's a good example. Yeah, I mean, I guess yeah, the reason I was very curious to have this as a topic for the community meeting is I think we need to be careful about stating I talked about this with you, Young. We need to be careful about, I guess, stating boundary conditions and error cases, right? We need to, I think, be very clear about when we can't figure out a V device, like when does it need to be annotated, etc. So that's what I'm hoping maybe we might be able to come up with, some solid rules, how it's supposed to work, what are error cases we should check for, what's not allowed, etc.
Thank you, Stephen. I think at this moment, what I saw is if we found the V device in the global info map of the R module, let me see, for example, if we have if we found the V device information in the global info map of the R module, then we know we have some global V device information there. Then for this case, we will check if the V device information is in the relax function. If there's no any if this, then we assume all the relax tensor structure, all the tensor structure info should have V device allocated. If not, we will probably print a warning to tell user to apply realize V device path. After the realize V device path, we assume all the V device information are filled in the tensor structure info. If there's some nodes has undefined V device information, I think we will we will raise an error. This is a rule I have at this moment. What do you think?
Yeah, if you have v devices specified in the global information, so is it the case every tensor should have if this is the case, you should be able to figure out the v device for every tensor in the program?
I think so. Otherwise, we will have some tensor have v device undefined. So we allow all the I think the rule at this moment I have is to allocate all of them, or can be inferred or realized or propagated through the path we have.
Okay. I wrote some text in the draft specification about V devices, so I encourage you to look it over, make sure it's consistent with what you believe about V devices. I think
I checked that today actually, so I think just a
Thank you.
minor change. I just need some very minor change. I didn't post that because after this discussion, if we agreed with everything, then we can I'll submit the change request to your
I
PR.
don't know. Yeah, just post it in the thread. Yeah, I'd like to figure out, because what I was concerned about when I was looking over this proposal, or it's not proposal actually, it's in Unity right now. It's in TVM's main branch right now. I guess we need to be careful, like I said, about error cases. So I think you could get into situations where like, for example, because of because of subclassing, or sorry, because of subtyping, supertyping, you could get into situations where you have two tensors on different devices. If you have a tensor with an unknown v device, you might need to check what device it's on. These are the sorts of situations where we need to define what's supposed to happen. Where we need to be careful to make sure, like, everything I wrote in the spec about V devices, it's to avoid situations where we can't figure out what the V device is supposed to be. So I'm curious to see what parts you were curious to refine. I guess okay. I have a question for you. Maybe this will make things easier. From the user's point of view, do they have to use hint on V device every time they want something on a different device? Like, is that how this works? The user puts in hints, and the passes figure out. They make it all flow down where different things are supposed to be located.
I think a hint-on device is kind of a hyper operator. So if user uses a hint-on device, I think it's fine. It will help us to help our realized V device path to know we will that input will be on a specific V device. User have the option to use hint-on device to help us to annotate or manually annotate it through the structure info. Also, if user do not want to annotate it, they can use I think this is also match cast as well.
Oh, I see. So yeah, this is one of the things. Yeah. So this was an issue that was
I thought
concerning to me.
thank you. Yeah, I saw that a little bit more. I think a hint-on device. I don't think we can just use the matchcast to replace the hint-on device. The reason is the matchcast will have if we use matchcast, we will have to specify the tensor structure info. For example, all the shape, all the tensor something, or we need to specify the tensor, the shape, the dtype, the bunch of this kind of thing. But using the hint-on device, as you can see here, we don't need to specify that kind of much information. That's one reason. Another reason is for the matchcast, we will do the runtime check. That means we do not remove the matchcast in the VM executable code, bad code, and we still have the matchcast there. but hint on device will be removed after we get the we get the v device field. Hint on we will not leave this kind of check in the runtime. I think it will introduce some burden to the runtime.
Whoa, wait,
Yeah,
hold on. So the runtime can't check which device a tensor's on?
For Matchcast, if we use Matchcast, we can use Matchcast if the V device information is in the we have V device information in the Matchcast. I think we can that information can help us to infer the or help us propagate the V device across the L for sure. We can do that. But the Matchcast will be always in will use the even in the lower pass. I think hint on device for this case, hint on device. I prefer you to use hint on device because hint on device will be removed after realize view device pass.
Okay, that makes sense. Yeah, so yeah, because what I want to make sure is that MatchPass will be Matchcast will be consistent with how it already worked. So the idea with Matchcast, right? You're checking things. You're checking things dynamically. So yes, it makes sense that we would check. You know, if you give it a device, it just makes sure that the tensor is on the device that you asked for. But okay, so realize v device, I imagine it has to insert copies, right? I must have asked you that before. Does it insert any copies?
Let me say, yeah, it will insert to V device. If, for example, if this device, for example, if the previous device is on CPU, then we for the follow-up operator, we allocated it to a different device. Then the realize V device, we will insert to V device to tell the backend to do the copy.
Okay, yeah, so that makes sense. So it makes sense that this is separate from Matchcast. Like Matchcast should not make things happen. Matchcast is just for
Yeah,
checking.
that's a runtime checking. So Matchcast is always there. So I think we do not it's not very helpful for this case. Yeah.
Okay, I like this policy. That makes total sense.
Thank you.
Yeah. So I guess the other thing, I just want to make sure that this isn't changing the way struct info works either. So we have the normalizer. Okay, so I guess actually, yeah, I think this might be all okay. So that's good. What I don't want to have happen is, and maybe I wrote this wrong in the spec, so it's worth checking that part of the spec. What I would like is for all the struct info, to be checked at the same time. That it should be easy to check that the struct info is correct. If the struct info is given, we should not have a hard time checking it. Realize v device, because the input program typically is not going to write out most of the v devices. That means realize v device has now this very important role in compilation. So important that it probably needs to be given in the spec. And I believe I put in a couple of paragraphs talking about realize v device.
You mentioned that. Yeah, I saw that.
So I think we should just make sure. Well, I guess you've had a look, I'm sure, at that part. Yeah, we just need to make sure that there's nothing like magic happening that's totally different from how a normal struct info checking works. So I guess you've written out examples, you've written out test cases. So I think I guess we should be like this example, for example, that you've written. It should work. So I think maybe my fears are unjustified. Maybe the way it's written right now is reasonable. I'm just looking for those two paragraphs that I wrote. A couple of paragraphs. Realize it's in here. Realize v device. Oh yeah, propagating virtual device information. Okay. Yeah. Okay. So I essentially wrote some paragraphs talking about how realized V devices
Yeah,
implement.
I saw that.
Okay. Yeah.
Thank you
That's
for
what I
doing
hoped.
that.
That's what I wanted your comments on. So I think it's fine because it only happens once. Does this is realized V device? Is that supposed to be used early in compilation? Is that the idea?
I think after the if we have the, for example, if we have the, I think the realized V device can be applied early, in the at the early stage of the combination of workflow, because the work is just to propagate V device information. Have this kind of information, doesn't hurt our follow up path, I think.
Right, it makes sense. I guess yeah, it does mean that passes have to think about what device things are located on, but I think that's reasonable. It hasn't caused we can see if it causes problems later. Hopefully different parts won't interfere with each other. So yeah, I think it's okay. If this is used early in compilation, everything's fine. I guess yeah, I just want to make sure that the struct info checking is all consistent. Like when we're in the early stage before doing realize V device, and then after you fill it in, everything should just work together. Like everything should work seamlessly. So that's what I'm interested in getting review on. Okay,
I
well, thanks.
reviewed the doc today. I think it looks very good. But if I have any change, I will let you know. Actually,
Okay.
thank you for doing
Yeah,
that.
yeah, read it carefully. I think now that well, fortunately the changes are merged. We have test cases. Hopefully we're going to use this. So I guess if problems arise, we'll know. I haven't spotted any huge inconsistency. We just need to articulate, I guess, what the boundaries are. The draft specification has my version of what I think the boundaries should be. So yeah, I guess we can talk about that offline. That those are my questions for you, Young. I'm happy to
Thank
to let
you.
other people talk.
Any other question from folks?
All right, if we don't have further questions, we can adjourn the meeting. This was the last topic on the agenda. If anyone has other things they would like to address in our remaining 7 minutes, you're welcome to raise a new topic.
By the way, since we have a vertical focus meeting on February 6th, so I encourage you guys to add a topic or something about that to the doc.
Oh, great. Let's yeah, we should make a louder announcement about the vertical focused meeting. It's exciting.
Yeah.
Okay, thank you, folks.
Thanks, everybody.
Thank you.
Thank you.